Welcome everyone. So this presentation is a kind of joint one between Zapper and Multiset. You're going to learn a lot about Multiset. Hopefully you know a lot about Zapper already and have joined all of our webinars in the past and have engaged with lots of our content. So my name is Chris Holton. I'm going to be emceeing the webinar today. I'm the sales director here at Zapper. I work predominantly with the platform side of the business. So if anyone is kind of interested in what Connell and Nick are talking about today, you'll most likely have a kind of follow-on conversation with myself or my team. So our speakers today are Connell Gould, who is the CTO and co-founder here at Zapper, and Nikhil Sorlani, who is the CEO and co-founder of Multiset. I'm going to let, I do call him Nick, so I'm going to kind of abbreviate that to Nick. But Nick's going to kind of introduce Multiset shortly. But rather than do that now, we've got a whole kind of slide and presentation on who Multiset is. So before we get started, please be aware that the event is going to be recorded. We normally send it out on our email mailing list, tomorrow or early next week. We do encourage you to use the chat function. We really love the questions. They really help to engage and make doing a live webinar worthwhile rather than just something that we pre-record and send out. We're going to have a couple of polls. We're going to have questions that we put up as well. As I mentioned, we are using a new webinar platform, so please forgive us if we have any hiccups there. But we definitely want you to be kind of active participants in the conversation. And then finally, we will be sending out a post-session survey. I believe it's only 1 or 2 questions, so it's not going to take you half an hour to fill in, but it's really valuable for us to get those insights and helps kind of shape the types of webinars that we'll be doing next year as well. So please do give us your feedback. So we've got a very educated audience today, I'm sure, but our agenda is going to be a primer on VPS. Then we're going to talk about why you should use Multiset as your VPS provider. We're going to talk about how the integration between Mattercraft and Multiset works. We're going to show you a few use cases. Wouldn't be a Zapper webinar without a live demo, so you're going to get one of those. And then we're going to talk about data ownership and deployment, which is really important for some of these types of activations that we're going to be talking about. I do want to give a shout out to Hideyuki, who is joining us at 1 o'clock in the morning from Japan. So thank you for getting up or staying up late to be with us today. Raphael, the webinar tool is Wistia. So yeah, it is very nice so far. We'll find out over the next hour whether it holds up. So over to Connell to tell us what is VPS.
Hey everyone, thank you very much for joining. Thank you, Chris, for the introduction. Lovely to see you all here today. Yes, so today we're talking predominantly about a technology called VPS. And the concept of VPS, even what it stands for, is Visual Positioning Systems. And effectively, VPSs allow you to take a camera image, such as the image coming from the phone, the camera on your phone, and determine the position of that device in the space that is captured. So in the real world environment that's represented by that image. And with VPS systems, you can build AR experiences and applications that then take place in that physical environment, such as factories or buildings or shopping malls. The image you see on the right of this slide here is a model of a physical space. Looks a little bit chaotic here. We'll see it later when we do the live demo. But this is the part of the office building here in London that we're based in Zapper. And that 3D model describes this physical environment, this real world office building. And the VPS system can take a model or a representation of the space that looks like that and resolve these queries from the camera to say, where am I in this building, given that I can see this little patch of space. And indeed, when we do the demo, in a little bit of time, we'll do a demo in this actual room, in our office room here in the building. And the camera images of this space behind us will be what the VPS system uses to therefore work out exactly where I am. in this room. So we can talk a little bit about what this type of technology enables. And there's a huge spectrum of possibility, but we'll talk about three. First of all, before we get into the demo, this is just, as I say, a small selection of the possibilities. VPS technology, and indeed Mattercraft as a tool, is a foundational technology that can be used to build any type of experience where the connection of the physical world and of some digital content matters. So a perfect example of this is indoor and outdoor navigation, where you take the position of the user in space so you know where they are. And then you've got that map of the real world environment that's been captured. And you work out where a destination is in that space. And then you can help the user navigate from place to place. So that could be, for example, in an office building, helping somebody get from the lobby to a meeting room. Or as in this picture, it could be helping somebody in a public space like a station or an airport or a hospital, these types of places, get from one location to the other. And of course, the nice thing about doing this with AR involved is you get this really nice effect of being able to literally show on the screen the path that the user should take through the space. It's also important to say that these types of experiences can be made accessible as well. So you can have users who are perhaps blind or have low vision have what is an AR experience, but where the audio is helping them navigate in that space, even though the phone is using a visual understanding of the space to work out where it is. There's, of course, a ton of industrial use cases, things like factory training and onboarding, where you take a space that has where the physical locations of things are important and the arrangement of the objects in that space are important, and you want to help somebody use that space better or more efficiently. And so a VPS can localize a mechanic in a factory, can help navigate them to a piece of equipment that needs maintained or fixed or what have you. Or it can help people route efficiently in a space and say, if you need to get from A to B to C to D to E, it can work out an optimal route for you to do that to minimize your time moving across the floor. So there's tons of interesting efficiency and utility use cases when it comes to industry and industrial settings. And then there's a whole spectrum of possibilities around brand marketing and activations where we really leverage the possibilities of what's possible in AR on the phone. So where we bring interactive 3D models, audio visual experiences, gameplay type mechanics, all of these things are possible and are fantastic where you want to, in a physical location, perhaps it's a retail environment, or perhaps it's a museum or a public venue where you've got marketing materials, you can bring those spaces to life in ways that really engage a user in that space and make an event out of the content that you are serving to your users. So all of these types of use cases all build on top of what is fundamental, two fundamental bits of technology: the ability to understand where you are in that space, that's the VPS element, and the ability to describe content to appear in that space. And that is, of course, what Mattercraft and Zapper's creative tooling enables. So why does it matter? Well, the physical and digital worlds that we inhabit are, of course, hugely important parts of our day-to-day lives. And these worlds needn't be disconnected from each other. You know, we see people walking around, their faces in their phones, and they're either ensconced in a digital experience or they're living present in the physical world and having a physical experience. What technology like VPS allows us to do is to connect these two worlds together, to say that your activity in a physical space can be improved with either context or user experience added from the digital environment. And likewise, in the reciprocal way, your digital activities can be improved with the context of the physical space you're in. So VPS can help know where you are in an environment to make a digital experience on your phone more relevant to you and more contextually correct. So for example, in the office building, by localizing into the space, I can see an exact list of all of the destinations in my building, the points of interest, and how long it will take me to get there. It can route me, for example, to the nearest restrooms, or it can help me know that there is a vending machine that I didn't know about near me, and so I can use that to help improve both my physical use of the space, but also my digital understanding of it. And it's VPS that enables these applications to get the best of both of these worlds. So at this stage, I'm going to hand over to Nick, who is going to give you an intro to Multiset.
Hey, thank you, Cornell. Thank you, everyone, for joining. I'm Nick, co-founder and CEO at Multiset. At Multiset, we are building tools to understand the real world, and one of that tool is VPS. We believe that understanding or perceiving real world unlocks so many value across multiple domains in XR, AI, and robotics. So the vision with Multiset is building that tool for developers so they can build their application on top of it to perceive the real world. Um, Going particularly in the tooling itself, the VPS that we have, I mean, we tend to call it scan agnostic VPS to start with. Uh, VPS has not been a new term. There are VPS out there, but when we started Multiset, the vision was we wanted to solve VPS problem completely at scale. What does that mean? Is we wanted to build a VPS that is precise, robust, and scalable for developers when they are building their experience. So to start with, the main data input to our VPS, we did not wanted to constrain on any specific format or type. So that's why we have built a scan agnostic VPS. What does that mean? That you don't need to go and remap from a dedicated device or a dedicated vendor if you want to implement a VPS in your space. You can start with your own iPhone or an iPad, but if you are going at large scale, you can also take one of the professional grade cameras like Mataports, Leicas, Nevis, and Xgrids of the world. What Multiset does is gives you a simple interface where you could convert any of your 3D scan that you already own into a VPS instantly, right? We have been ranked as the most robust VPS from Area, which is one of the top community of in AR and VR for comparing different tools. How we differ from existing VPS is in terms of how robust we could be and how scalable we could be. For example, our VPS works in different lighting and different weather without needing of a constant remapping. So unlike existing VPS out there, you don't require a constant remapping every 6 months or a year if the weather changes or if the environment has slightly changes or if the lighting drastically changes. Even in if you map in a bright light and you localize in extremely low light, the VPS is still going to function uh, to the accuracy that we claim. Our VPS is capable of localizing in a median accuracy of 5 centimeter. What does that unlock? So having such high accuracy unlocks that your XR content are precisely anchored to the real world. So there won't be any drift. The XR content would be precisely placed where you want those them to be placed in the real world. Another advantage of our VPS is how you could represent the environment. So in middle of this picture, you see a very photorealistic mesh. This photorealistic mesh of the environment unlocks a lot of values for developers when they are authoring their experiences. As Connell was mentioning about navigation, accurate mesh could help you in multiple phases of when you are building applications like indoor navigation. It could help you in occlusion. It could help you in detecting surfaces for accurate path detection and path finding. So just improving the visualization of a VPS output unlocks so many values in a new application which could not be built earlier. I'll be walking to the next slide, but before this, we have a cross-platform SDK that works out of the box in Unity, and now with the integration with Mattercraft, it just unlocks all the value on the web. So you can directly build in the web and publish to the web without building native apps or without a mandatory native app as well. Uh, Moving to the deployment types. With VPS, one of the problems that we're trying to solve is the problem of data ownership. Since VPS deals with a lot of spatial, confidential, and private data, we wanted to give developers the flexibility on choosing how they want to deploy the VPS. They can start with deploying on our own cloud, or unlike other VPS, the data in your account on our own cloud is private to you. So the data does not becomes public, and you would only have access to your own maps. But if you want even more security, we give options of private cloud. With what does that mean? That you could host our VPS in your own private cloud, whether that's AWS, Azure, or Google Cloud. The third and the most advanced option is on device. What does that mean is you don't even need to set up a server or send any camera frames on internet. You could actually download a VPS map and run it everything end to end in the device itself. So that just makes the deployment process easier. Everything that you need, the compute, the code, and the map sits in your device, and you don't need to manage multiple servers linked together. Thank you, Connor.
No worries. Thank you, Nick. So we will be doing a live demo, as Chris mentioned. But before we do, I thought I would talk a little bit about why Multiset and Mattercraft together are special, and we will see examples of a ton of this when we get to the live demo. So for those of you that maybe don't know Mattercraft, it's Zapper's complete 3D development environment for the web. So the content that you build in Mattercraft can be dynamic 3D experiences. They can involve animation and state and gameplay, you name it. And crucially, when you're building that content and you're publishing it, it's a web-based deployment flow. So Mattercraft experiences are basically web pages. And what we do is provide an app clip, which means that when end users want to access your experience, they can scan a QR code or they can tap a link. It can take them straight into a very high quality, fully 3D tracked experience without them having to visit the App Store. Now, even though it's a web-based environment, what Mattercraft does is mean you don't have to compromise on the types of content that you build. And indeed, with Multiset, all of that Mattercraft functionality is available. So as you can see on the right, we have a full visual preview of the map that you want to build content for. We provide a structure in your scene, such as the Multiset anchor group, and that's where you can position virtual content to appear in that space. See an example of that, of course. And that group provides events for things like when a successful localization has happened in that space. So where the Multiset system has been able to correctly work out where you are. And that allows you to build custom user interface and custom user experience, depending on the type of application you're trying to deliver to users. We have brand new functionality in Mattercraft around NavMesh. Now, NavMesh is technology that can take a 3D model of a space, like what we see on the right, and it can automatically work out the areas in that space that are walkable. So effectively, the kind of the floor and the flat areas, and that can be used for then querying that navigation mesh. So where you say, I'd like to understand the shortest path to get from position A position B, and the nav mesh will make sure that the path that is generated avoids the obstacles. It goes up the stairs. It goes, around things that would be in your way. And so there's a slightly computationally complex problem to solve, and the navigation mesh solution in Mattercraft helps you do that automatically from the Multiset mesh. We'll see that. There's some additional functionality in there around navigation connections. So sometimes, for example, if you've made a scan of a big office environment like this, there'll be things in the mesh, the visual representation of that space, that look like they're non-navigable. Like if a door is closed in the mesh, then that's going to look like a wall in this. We'll see some examples of this in the live preview as well. And navigation connections allow you to say, there's actually a connection between this bit of the mesh and this other bit of the mesh. So you could use that for connecting, for example, two sides of a closed door, or you could use it for connecting the floors in a lift lobby, for example, so that users know that they can, and that the system knows that they can route a user via the lift lobby rather than having to go all the way up the stairs. And in general, multi-floor routing support is possible. And then we have additional integrated behaviors for triggering UI and animations based on the different events that can take place in a VPS located environment. And so there's a 3-step process to building a VPS experience. And as I say, we will see this in the live preview. But the first is scanning the space. And so as Nick mentioned, Multiset have a number of options for that. And so on LiDAR-equipped iOS devices, so iPhones with the LiDAR, the ones with the little bit here, you can download their app and literally just scan into the space, and we'll see how that works. But as Nick says, you can take things like Matterport scans, so scans where you have some specialized equipment for capturing bigger environments, and those can be brought into Multiset for the purposes of the VPS. And often big, buildings will have Matterport scans already of those spaces. And if not, that's the kind of thing that you can, can contract a company to come and make a Matterport scan of a space. Once you've got that scan and you've imported it into Multiset, then you can take it into Mattercraft and you add your credentials and you add the ID of your map, and then the visualization appears. And from there, you can start making your content. At that point, it's exactly the same usual process that you would make content with any Mattercraft project. All of the same add-ons and dependencies and features, animation, particles, physics, all of those types of things are just supported in the usual way. And then the final step is, of course, publish. That's where when you're happy with your experience, you can make it available on a QR code or on a URL, and that is an instant process. As soon as you hit publish, users can take that URL or that QR code and in that physical space, view your content and access it.
Connor, we had a couple of questions, so I think now might be a good time.
Yeah, please.
So you mentioned on the previous slide about the LiDAR camera, and we had a question from Christian who said, is LiDAR mandatory on mobile devices? So I think there's some nuance between the scanning and the end user. So maybe you could explain that.
Yes. So end users, so people, after you've built your experience, end users using the environment do not need to have a LiDAR-equipped device. So when it's being consumed by an end user in the space, it's any of the devices supported by Mattercraft. So that's iPhone and Android, and whether or not it's got a LiDAR or not doesn't matter at all. It's just during the process of scanning this space as the beginning of your creative development process, that's when you would use the LiDAR. And then in the live demo, I'll do a little bit of mapping of this space just to show you what that looks like. And you'll see exactly the process that the Multiset app is doing to build that map and that space and the spatial understanding of it. And that's the only time the LiDAR is needed. After that, end users can use whatever they've got in their pocket.
Yeah, so Christian, I hope that answers your questions. For the end users, you don't need LiDAR on device. We had a question from Peter Townsend who said, could you expand a little bit on the idea of the app clip, Connor?
Absolutely, yes. So most of the time when you're building content with Mattercraft, it sits in your web browser. And when the user scans the QR code or the taps the link, it takes the user into the web browser where they have their experience. Sometimes we want to give the user an experience that where the tracking of the world is a very high quality level of tracking. And in particular with VPS, that's really important. And to do that, what we enable is the app clip, and I'll show it in the demo. Effectively, when the user scans the QR code or taps the link, we take on iOS, on iPhone, we take the user into a little like mini app, if you like, on their phone. The iOS operating system loads that up automatically. Users don't need to visit the App Store or anything like that. It just launches automatically. And that allows us to exactly the same project built in Mattercraft, but to provide very high quality world tracking using ARKit, the tracking technology that's built into iPhone. There's a ton of technical reasons why the app clip is always going to be better for that type of tracking. It comes a lot down to just the fact that on iPhone, the native world tracking has full access to the sensors on the device and to the calibration that performed when the phone is in the factory that we just don't have access to in the web browser itself. But the beauty of our system with app clips in Mattercraft is that as a content developer, those details shouldn't matter too much. You can just provide the user with a QR code that will take the user into that experience. On Android, we use a similar technology called WebXR to get the same high quality tracking. And we're able to do that in just the normal Chrome browser on Android. Let me know if that answers your question.
Well, you did get two questions. Does it work on Android devices? So I think you've covered that one, Connell. So Raphael, Faisal, and Salah, I'm going to push your questions back a little bit to the Q&A just because I want to let Connell get to the live demo. But I have seen your questions, and I'll make sure they're answered before the end of this session.
Fab. All right. Thank you, Chris. Well, why don't we get to the live demo then? So I'm going to stop sharing. I'm going to do a little bit of juggling of screens and windows and things so that I can share my screen. So what I will do is I'll just tap share entire screen, and what we might get is infinite windows of the infinite tunnel of screen share. But what I'll do in the first instance is I will take this, which should show the screen on my phone. So I've got the phone here on in my hand, and the very first thing I'm going to show is just what the mapping process looks like with Multiset. So if I want to start capturing this space for the purposes of then building content in it. And so I'm going to open the phone here, and I'm going to head over here where I've got the Multiset app, which I downloaded from the App Store. I should say, as we discussed, this is only necessary for the creative developer in this process. And by tapping plus, I can go create VPS, and Multiset have a nice onboarding UI. But in any case, once we get into the experience like this, and I look around and I tap the record button, what we'll see is that the Multiset app starts building a map of the space. If I look over here, you can see it sort of starts building a mesh of the space. What I would do is I would use this process to go and capture the room. I'd walk over there and get the kind of corners and look from different angles, etc. And then once I'm finished with that, I press stop. And at that point, that data can then be uploaded into Multiset's system. So I'm not going to upload it in this case because in true Blue Peter fashion, that's a British reference for a British TV show, so maybe not for everybody, but in true Blue Peter fashion, I've got a version of this map that I've captured already, so we can see it straight away. So let me just pop the phone down now, and we'll pop back to the screen and go to Mattercraft. So here's Mattercraft. I've started a completely blank project just to show you the process of creating a multi-set experience with Mattercraft. What I'll do is I'll scroll down here, and in the VPS section, we will see the VPS options. I'll talk a little bit about Immersal later. It's another VPS provider we support as well. But of course, today we're demoing multi-set, so I'll select that and go get started. And Mattercraft will prepare our project for us. The sample project we're about to see comes with the map for our office already input so that you can see something on the screen and get started straight away. But in just a moment, we'll talk through the process of how we would set it up with our own map. So if I have a little look around here, we can see the space that I'm in. This is the mesh that was generated during a process very similar to what I just demonstrated with the Multiset app. And we can see here that there's a chair, a virtual chair that's been added into this space, that I can move around and what have you. So just a little 3D model there to demonstrate it in that position. What I'll do first of all is a little live preview of this so that you can see what it looks like for an end user. And then we can go through how the scene is set up so that you can get a handle for just how easy it is to start building the content. So Mattercraft has its live preview feature that allows me to give this a try. So I'm just going to scan this with the phone. I'll bring up the phone share again. I can get out of there. And I'm going to scan that QR code like this. It's going to open the app clip. So this is the part of the process where that a tiny little mini app is going to be used to launch my content. And you can see I'm not in the App Store or anything like that. I just scanned the QR code and then tap Open App Clip. And then from this point on, it's my usual Mattercraft experience. I tap Launch, and then we have a look at the space, and then as soon, and you see how quickly the multi-set VPS system managed to detect the space, and we can see that that chair is now correctly positioned in the real-world environment of my office here, in exactly the place where we described it in the scene in Mattercraft. And as you can see, the quality of the tracking is really good. Like I can be, sorry, I hope that doesn't make anybody nauseous. I can really mess with the tracking, and the system recovers really nicely and just gives really high quality, proper tracking of that environment for a really robust end user experience. Cool. Okay, let's have a look back in Mattercraft, and we can have a little look at what the options are in terms of building and configuring your space. And the most important group for us to look at is this multi-set anchor group object here. And there's some settings here that allow you to connect the map that you scanned in the multi-set app with the Mattercraft environment. And so what you would do is you head to the developer.multiset.ai section with the maps, and you can see all of the maps that have been scanned in by your multi-set app, and that gives you that map code here on the right, like this. And if I pop back to the experience, to Mattercraft, sorry, you can see that that goes into this map code. The client ID and the client secret are two credentials that the system uses to authenticate you against the multi-set platform. And so it's just like the username and password, if you like. But what multi-set have done, they've provided the ability to generate these read-only credentials. So you can say, instead of write credentials, just give query credentials, and that gives you a client ID and a client secret, and those credentials are only able to query the map. And that's exactly what we want for a web-based distribution of content. These credentials are going to end up in the web page that the phone accesses in order to scan the space. And by having read-only credentials, we know that those credentials can't be used to write or change the system at all. And so that's why I'm also perfectly happy to be showing them here on screen, because all they are read-only credentials for the purposes of letting the map be shown in the editor here, and to resolve those queries to take a camera image and find out where in the space the device is. So there's a ton of other options here. There's lots of detail to talk about, and we've updated our documentation site with information about how to be working with multi-set. If I look down, there's some really interesting settings. Multi-set have an API that allows you to submit multiple images to their system at once. And so in areas where accuracy is really important, having multiple images submitted together means the multi-set system can give a really accurate response. And so there's a ton of different settings for tweaking and tuning depending on your environment. If we have a look down here, there's animation options for having timelines and animations play depending on when the user successfully localizes into a space. So that is the core of the multi-set functionality. It's as simple as that. From the template, you get the anchor, multi-set anchor group, and anything you place in that, like this chair, will end up correctly localized in that real physical environment based on the localization from the VPS system. Now, there's one thing else I'd like to show, which is some of the more advanced navigation use cases. Now, we don't have time to do this section proper justice because there's lots of functionality and flexibility here. So I have instead put together a little example already, which we can load in and we can take a look at. So I'll just zoom out a little bit. This is the map of the bigger office space that we're in. It was shown on one of those earlier slides. And there's a few additional elements we've added to this. So the navigation mesh, for example, and what you can see is if we zoom in, and I'll see if I can find a nice angle that shows it. But what you can see is the navigations mesh is this yellow surface, and it has found all of the walkable area within this environment. So you can see that there's bits of wall and furniture, etc., where the navigation mesh avoids. And if I go up here and look, I'll go a little bit forward. You see this corridor here, for example, the walkable area is detected down the center of this corridor. Now, we spoke a little bit about navigation connections. And so if I look over here, this is a door in this environment. And you can see that the navigation mesh stops at this door. And that's because, according to the navigation mesh system, it looks like a wall. The door is something you cannot pass through. And so what we have done is added this navigation connection here. And we basically have two ends of this navigation connection, and we use it to say that actually you can pass through this door. You can go from this side of the navigation mesh to that side over here. And it's with these mechanisms that you can take what is, as you can see in this case, a model that's not perfect. You know, it's got doors that are closed. It's got other bits of incorrectness in the mesh, and you can make it work with a navigation solution just by instrumenting a little bit with these things like the navigation connection. And then the final bit to show is we have this navigation route object. And what we're saying here is we'd like to do a query on the navigation mesh between an origin and a destination. And in this case, the origin and destination are just two groups that I've positioned in this space. So in this case, the origin is here, down on the lobby at the entrance. And the destination is up here, all the way at the other end of this mesh. And the breadcrumbs are is an object that shows this little set of dots that you can kind of configure and customize, make it Zapier red, which is any red, basically. And let's see, we can see that that route is following the navigation mesh. So obviously, for an end user, you probably wouldn't show the mesh itself, but if you wanted to help a user move from this location all the way upstairs, you would show these dots. And that would give you that navigation. And if I select the origin, we can see that the navigation mesh computes this path in real time. So as the user moves around in this space, the mesh is up to date with the correct path to take the user to where we want to go. And the navigation mesh has a ton of options for configuring things like how close you can get to the walls, what the minimum width is for navigation in a space. So for example, you can make sure you can have multiple navigation meshes, one that's suitable for perhaps users in wheelchairs where they need more space versus users without. And it's the same with stairs and steps. So you can have a version of the navigation mesh that's that's step-free, for example. So there's a ton of functionality in the navigation system that goes beyond just the core localization and VPS, and we're continuing to work on furthering and improving the types of things you can do with the navigation mesh and the routing. Cool. Okay, that is a whistle-stop tour of the multi-set and navigation functionality. Chris, is there anything I've missed in the live preview, do you think? Live preview, the live demo?
No, we've had lots of questions come in, so I do want to make sure that we have some time for those. I think on the demo piece, I think we're okay. A lot of
Nice.
questions about multi-set and scanning technology and how big the scale can be. So, no, I think it's. Oh, we did have one question that might be relevant. So we had, how much will changes affect the tracking? So for instance, if the kind of wardrobe unit behind you was moved, how much would that affect the tracking? Might be a good one to pick up now.
Yeah, that's maybe a question for Nick. Nick, could you
Yeah.
like to?
Sure, yeah. So with Multiset, I mean, we are trying to build a dynamic VPS, so that could handle change in lighting, whether it's low light, dark rooms, highlight, sunlight glare, or even small changes. If you move a wardrobe or move your chair, once the map is created, this would not impact the localization accuracy or performance. As Cornell was saying, we have a single frame localization which looks at one frame of a map, but we also have something called multi-frame localization, which looks at the bigger picture of your environment, like up to 4 or 5 frames, and then tries to understand your location with respect to the mesh. So it's really doing like how large language models works. It's actually thinking uh, about your environment and comparing it with a database to return you a very precise pose in difficult conditions.
Top. Thank you, Nick. And then again, one that might be, because does this work for headsets as well? So could you develop with Mattercraft and Multiset for, the MetaQuest or any kind of headsets providers that are out there?
That's a great question. I can take that one with regards to Mattercraft, and then Nick can maybe speak after that, if you're happy to, Nick, about targeting headsets with your native like pipeline and Unity. But certainly in Mattercraft, in WebXR, which is I suppose, the specification that you use when you're building content for headsets through the web browser and headsets. Quest has actually very recently released support for accessing the camera in that environment, and that's something we're beginning to look at here at Zapier. So I suspect in the future for some headsets, such as Quest, that will be possible. It's not something that's available right now because we want to give it a good try and like work out all the kinks and make sure it works well. But that's definitely something to look out for in the future. Other headsets, so certainly the Pico and Vision Pro, the Snap Spectacles, I don't believe they provide web pages with camera access at the moment, and that's the challenge for us. The WebXR specification by itself doesn't give us camera access, so it's something that the browser maker has to do and has to make available. Quest has done it, the others haven't quite yet, but we'll of course keep an eye on that. Over to Nick. I don't know if you want to say anything, Nick, about if you're building native apps for these headsets and VPS in that case.
Yeah, we do have a native Unity SDK dedicated for MetaQuest. So that uses the native pass-through API with which MetaQuest provides. We also have tons of tutorial with MetaQuest as well. So I'll drop a link of our documentation for developers interested in building on MetaQuest, but this is through Unity right now. And as Connell mentioned, this will be soon available through MetaCraft as well.
Brilliant. Yeah, I suggest we move to the next part of the presentation.
Nice. All right. I will share again the slides. So I should mention that we also support Immersal. Immersal is another VPS provider with a slightly different set of features and functionality versus Multiset. And Mattercraft supports both of these, so you're welcome to look at both and choose whichever is the right technology for your project. And we've got an example and a template for Immersal as well as Multiset. I thought I would mention that.
We did have one question about Alki as well, Connell. Maybe you could just touch on Alki at this slide as well.
Absolutely. So we have a partnership with another company as well called Alki. They have a system which they call a distributed sense of space. So that's where you put QR codes in an environment to allow you to do the same VPS type solution, or at least to position yourself in that space. And with Alki's solution, it uses QR code detections to work out where you are. There's pros and cons for both VPS and for Alki type solutions. the Aukey solution, for example, is great for incredibly chaotic environments where that space will look very visually different from day to day or what have you, where large amounts of the environment are rapidly changing. You can imagine things like retail environments, like shops, where the products on shelves are changing as people are taking products on or off the shelving. The disadvantage or the other side of that is you have to put QR codes into the space. So it depends on your use case, which is the correct solution to go for. At Mattercraft, we do have an implementation of the Aukey running in Mattercraft. There's not a template for it at the moment, but if you're interested in that, just get in touch with us. I'm sure we'll be adding a template soon.
Great.
Nice. Fab. And I thought I would pass over to Nick to talk about something that's already in Multiset, but that will be soon coming to our implementation of it. Are you happy? Well, I just press play on the video in the background here, Nick?
Yeah, that's okay. And I think there was a question in the chat as well about...
There was, yeah. I was waiting for this slide to come up, so I didn't want to ask you guys and preempt it.
So with Multiset, we also have a feature called Model Set, which is AKA object tracking. So also, I mean, it's going in both the directions. So you can scan as large area as possible, but also you could scan specific point of interest or objects per se, right? So it could be a coffee table, it could be a car engine, it could be a washing machine, and you want to overlay accurate instructions on top of that object, and instead of scanning the whole room or a whole space, you want to just overlay precise instructions or have AR overlays on that specific object. With Multiset, you could simply scan that object through any app of your choice and export that object as a GLB, import that GLB into Multiset developer portal. What we do instantly is convert that single GLB scan of a model into an object tracking API, which could be easily accessed through our Unity SDK as well as through web soon from Metacraft as well. So what does it allow here on the video? What you're seeing is I imported the scan, I uploaded into the multiset, and later I'm able to localize against that small scan and able to overlay very precisely at millimeter level the AR instructions. So here I'm just overlaying where is the washer fluid, how do I put in the engine oil, and things like that. So it goes in the both direction. Our VPS is general purpose, so it could either scan large areas, but as well as also take scans of small objects as well.
Perfect. Thank you, Nick. And yeah, as we say, that functionality is not in our Mattercraft implementation quite yet, but it's coming very soon. And if you are interested in this, just drop us a line and we'll make sure we can get you access as quickly as possible. Nice, cool. Well, I think we now get to our dedicated Q&A section. So I'll stop sharing, and then Chris, I don't know if you want to
yeah, we've had
really
active chat and really active Q&A. So I'm just going to try and kind of group them together. Let me just see. There was a couple. So we've had a couple of questions about scale, and maybe one for Nick, but Connell, you might want to speak about it as well. You know, what kind of scale are we talking about with these types of maps?
Yeah, Nick, do you want to go ahead with the kind of VPS side of things, and then I can talk a little bit to Minecraft?
So with Multiset, I mean, this is one of our goal to make a VPS system almost infinite scalable. So today with single scans, we have scaled up to 5 million square feet in a single, let's say, scan coming from a Matterport or a Naviscan. So when we're talking about scale, we could do large power plants, large shopping malls, train stations in a single go. With Multiset, we process millions of square feet of area almost every day. And in fraction of the time what existing VPS takes out there, and producing high quality mesh as an output. So scale is almost infinite also with our feature called MapSet, where you could break the scanning into a smaller, relatively smaller components. Let's say you could scan in pieces of 100,000 square feet and then later merge them together very easily with our MapSet feature and have a really large scan built on top of it, and that also produces a high quality mesh. Um, I also saw a couple of questions on the quality of the mesh with Matterport and Navis. So I'll just try to answer that as well. So if you when you have a professional grid scanners, the quality of mesh is even better. So what you saw in the demo with Cornell shot is from an iPhone Pro camera, which has a limited range and cameras. But when you go with the professional grade cameras, the quality of the output and the localization is even better with them.
Yeah, and we had a couple of ones, Nick. How do you handle kind of daylight, daytime, nighttime? How does the technology handle that?
Sure. Before that, Connell, you want to explain the scale of, I think, authoring side of things, because when you are loading so large meshes, like large as a million square feet, how do you handle the efficient authoring of that?
Yeah, absolutely. I can talk to that very briefly. Certainly in Mattercraft, you're working in a web environment, and the amount of memory that's accessible to your page running in the browser is more limited than in other places. But that said, we're able to do some interesting optimizations on the 3D models and the meshes that are in the space. Some of those we've done already, and there's more to come on that mean that Mattercraft experiences should be able to scale to the same sizes that Nick's talking about, the really big environments. It's our expectation that with an experience built in Mattercraft, you can take a user from one end of a shopping mall all the way to the other end of a huge shopping mall, and that work within that Mattercraft and web-based environment. There's other interesting things for us to work on as well to make that even easier around literally just how you navigate. Do I still have you? I think the screen popped away.
We lost you momentarily, but you are now back.
Okay, no idea what that was. And the point I was making is there's a ton of kind of user experience stuff that we can do in Mattercraft as well as we build out to these bigger environments and these bigger spaces, just to make it easier to sort of navigate around the model and what have you. So there'll be more of that to come as well. But for the moment, you should be able to build content in moderately sized spaces for sure.
Yeah, and to answer the daylight question, and this is something we wanted to solve from beginning, because with existing VPS, the recommendation was always you have to scan in day, evening, artificial lights, and we wanted to avoid that, because when you go into production, managing so many versions of the map simply becomes almost impossible. So we wanted to build a very dynamic VPS which could actually adapt to the environment. So I dropped a couple of videos in the chat where we did a scanning of a very, very busy streets early morning, almost low light or decent light, and then we localized in that street, which is full of people, full of moving objects like cars, bikes, and we still, even in that situation, we could localize it 99% of the time with the 5 centimeter median accuracy that we claim for. We have a couple of videos and demos that I just shared in the chat as well for audience who is looking for actual demos. We would love to have you to try as well. You could go and scan your places and simply turn off the lights of your environment, and localization would still work even without having all the lights that you had during the scanning. We could work in as low as 6 or 7 lumen of lights.
Brilliant. Yeah, sorry, we have lots of questions. We had one, does deployment of VPS on device affect performance? I think this is back to your point earlier, Nick. Is the deployed VPS asset lightweight?
Yeah, so we have multiple ways of deploying VPS. One of them is on device. So with on device, unlike other VPS, our VPS does use all the compute that is available on that device, which means it's not just relying on CPU. Our VPS relies on GPU as well as NPU available on those devices as well. So we try to use the complete resources. So that makes our VPS very efficient. So it will still have minimal performance impact, I would say, compared to an on-cloud VPS, because the code as well as is running completely on device, but it won't be unbearable where you simply can't use the device. And the good part is, irrespective of the map size, our VPS performs the same, which means the localization response time, irrespective of map size, would be almost similar. Which means like you don't have to scale. Okay, it's working in my apartment, but when I get it to the production, it's not working. With multiset, that's not the case. So irrespective of scale, we're going to get similar performance and accuracy, whether it's on device or on cloud.
I might just add one thing on top of that, which is to say that multiset's on-device functionality is part of their Unity SDK at the moment. And so hopefully we'll be able to bring that to Mattercraft in the future. Just as a cheeky aside, there is also on-device functionality supported with Immersal at the moment, currently in Mattercraft. But hopefully in the future, we'll have multisets running there as well. Nice.
And there were a couple of questions on drift. So Zafir said that they were indoor navigation at the university with an iPhone 14 Pro Max. Drift occurs during scans in large areas. How can these deviations on the mesh formed after scanning be reduced or prevented?
Yeah. So yeah, I think for the large scale, definitely, if you are scanning from an iPhone Pro for, let's say, a whole university, there will be always some cases where there is drift, because obviously the quality of the scan at large scale, because of the sensors and the iPhones, are limited. So what we typically recommend is, if you are going at a campus scale or at a shopping mall scale, go with a professional grade camera, which
Yep.
could and you could, like, you don't need to always buy that camera. There's a lot of service providers who could come scan that space for you and give you a E57 file, which you can directly ingest into multiset instantly.
Nice. And then a bit I can add on that as well. So that's, I suppose, from the scanning perspective, originally, when you're building the map and making sure you don't bake any drift into the map building process, then obviously when the end user is moving in your space subsequently, there's some techniques that are already available in the multi-set integration into Mattercraft around relocalizing as the user moves in the space. So you can say, if they're moving every 30 seconds, we'd like to relocalize with the VPS, and that just neutralizes any drift at that point. So just keeps the user accurately in the space. And there's some other options around saying, when the user moves by a certain amount in the space, you want to trigger relocalization and these sorts of things as well. So if you do find, and some spaces will be more susceptible to it than others. So for example, spaces that have got really shiny floors or shiny and reflective surfaces, for example, are more likely to drift with something like ARKit than others. But you can neutralize all of that by just relocalizing as the user's moving in the space against the map.
Very good. We've still got lots of questions. We are at time, but I don't know, Nick and Connor, if you want to go for another couple of minutes just to wrap up the questions. We've still got a bunch of people watching, so not many people have dropped off. So, but please do feel free, and the live recording will go up on our email channels, and you'll be able to access it on our website as well. So we had, let me see. We had a question from Gordon, who said, would it be possible to scan an area outside of a city, for example, an empty construction site on which I could display virtual buildings? For example, if I scan a QR code on a construction site. That's basically the question. Yeah.
That's a fascinating question, and I think there's two elements to it. One is the type of the space that is. And so Nick can probably speak more to this, or better to this than I can, but you need to have at least a little bit of structure in the environment for the VPS system, for any VPS system to work, as long as you have some geometry around, like objects or trees and fences and bits of building and that sort of thing, I imagine it will work. Nick, this I should have just let you answer this. Is that broadly accurate?
Yeah, yes, that's right. So I think for any sort of visual positioning system to work, we need to, how does system works is they look at the real world and compare it with the map of the real world that you basically inputted at the time of creation. So as long as there is enough features to be matched between what is today on the construction side and what was mapped, it should be able to localize you and anchor your AR experience very easily. Typically for outdoors, we really recommend going with professional grid scanners because those have range of up to 100 meters of what they could scan. So even if it doesn't scan your construction site, it could actually scan the nearby areas. So when you go and localize, it will try to match by the nearby areas and place your construction assets accurately by referencing to those nearby areas. So that's why having a good range when you are mapping is very essential depending on what sort of experience you are building.
Nice. Hopefully that answers your question. If you and if anybody on the questions that we have answered so far would like further information, of course, just feel free to reach out. Chris, any others?
I think we're pretty good. Yeah, maybe we could just let people know how to get in touch with Nick and the team at Multiset and on the Zapper side. I don't know if we have those slides or do we have a slide with contact?
Let me just verify. The only slide that we have missed is one that says thank you, which is obviously a very important slide. But we can definitely follow up afterwards with the contact information, and you'll have the recording as well.
Yeah, so from our side, if you have any questions, please just go to zapper.com. We've got a contact form, really easy to find, so you can reach us there. My email, if you want to reach me directly, is chris.holton@zapper.com. And Nick, from you, how do people get in touch with Multiset?
Yeah, so we have on multiset.ai, you can do a contact form. We also have a Discord community, which you can get access to on our website. You can join our Discord community where we answer questions 24/7. Our platform is open. There is also a free tier available. So in case you want to try it instantly, it has access to all the features. So you can start building with Metacrafts at Multiset instantly.
Yeah, and to echo that as well. So ZapWorks has a 2-week free trial. So if you haven't already, please do sign up for that. You can kind of test everything that Connell and Nick have been speaking about for the past hour or so, completely free. If you need more time, then we also have a developer plan as well, which costs you about $11 a month or something like that. So just kind of doing your evaluations is really cost effective. And then if you want to kind of go to a production grade or on a commercial project, then Nick and his team or as well as Zapper can kind of take you through the pricing of how much that would cost. But yeah, I think let's kind of wrap up there because we have run over, and I know I'm sure people are wanting to get on with the rest of their days, especially our watcher who was in Japan, who is now past 2 o'clock in the morning. So from me, thank you, Connell, and thank you, Nick. It's been a really enjoyable presentation. And yeah, any last words from either of you?
Just to say thank you very much to Nick as well from me, and of course to everyone for joining. Hopefully we got through all of your questions, but if not, please do let us know. And yeah, thanks for listening to me yabber on.
And Nick, as our guest, would you like to have the final word?
Thank you for joining, everyone. We would love to see you what you build with Multiset / Metacraft together.
Great. Okay, thanks for watching, everyone. We're going to end the presentation now. Cheers.
Cheers.
Bye-bye.